Precalc chapter 9 section 2. So this is all about ellipses, conic sections that are ellipses. So an ellipse is a set of all points x, y in a plane which has a constant sum of distances from two distinct points called the foci. So in the ellipse we have these foci, so they're like a focus, just plural. So we have focus 1 and focus 2. So the distance to the point on the ellipse, if you add up d1 plus d2, that distance is going to be consistent for all the points on the ellipse. So that'll be the locus for the ellipse. Now, standard form for the ellipse, we have h and k is still the center of our ellipse, and we have two different axes. We have the major axis, which is double A, and the minor axis, which is double B. And we'll learn what A and B is here in a second. So we have the two axes. We have the horizontal and major. So here is our horizontal equation, and here's the vertical one. And then you notice how each of these still has the HK, the shifting. Here the x values are divided by A, and the y is divided by B. And then for the vertical, now the y is divided by A and the x is divided by B. So notice how that changes. That's really the only thing that changes in these equations, is how the A and the B shifts. So then the foci is always C units from the center. It can be found using this equation, c squared equals a squared minus b squared. So we'll use that equation to find our foci. It's at the center. If there's no shifting, we just don't have the h and k's. And there's also something called eccentricity. Eccentricity is how oval the ellipse would be, how skinny, how circular the ellipse would be. So the closer to 1 the eccentricity is, the more elongated it will be. And so you see the E equals C divided by A. That's how you find it. And C is the distance again from the center to the foci. And then the A and B, we need to discuss that. So let's go back and try to figure out what our different shapes are. So here, if we're given an ellipse, so we have this ellipse on the outside, and we have the foci. We have the center point in here, the center. Then we have two different axes. It depends on if it's a vertical or horizontal ellipse. Because it's longer horizontally, this would be a horizontal ellipse. So the horizontal, the distance from the center to the foci, we just said was C. Now the A and B, A is the distance from the center to the vertex. So we have these vertices out here, and the distance from the center to the vertex is A. And then we have what's called a covertex. The other points, these are called covertices, covertex, and the distance from the center to the covertex is B. And so those are the dimensions we're going to have. Notice how for an ellipse, our A value is always going to be bigger than our B value, because it's stretched out in that direction. A is also on the same axes as C, so A and C, the foci and A are the same horizontal line if it's horizontal. And so that's the different parts of an ellipse. So let's find the standard form given the center, the vertex. We have the vertex, we have the center, and then the minor axis. We've not talked a whole lot about. Now on the equations here, we know the major axis is double A, the minor axis is double B. And we talked about what B and A were already, the distances from the center to those vertices. So if I sketch this out, so center is 2, negative 1. There's the center. The vertex is 2, 1/2. So vertex. And so the minor axis is the opposite direction from this. So the center to the vertex, if I go up 1.5, and I also go down 1.5, so up 1.5, and I also go down 1.5, I'll find the other vertice, and that'll help me graph it. But I then know my minor axis is the other direction, is linked to So then B is going to be half of that 1. 1 to the left, 1 to the right, and I can sketch my ellipse then. So in this ellipse, we have our co-vertices here. So this distance here is B. The distance from the center to the vertice is A. Center to some foci is C. So in this, we have our center. So our center, which is HK in the formula, is equal to 2, -1. We have our A value, which is the distance from our center to our vertex, which is a distance of 1.5 or 3/2. We have our B value because it's half the minor axis, which is 1. So we do not have is the C value. This is the center. So we do not have the C value. We can find the C value by using the equation C squared equals A squared minus B squared. And so then we don't know C squared, but we know A is 3/2. If I square that, I get 9/4. Minus 1 squared is 1. So C squared equals 5/4. So then C is equal to plus or minus √5/2. So now you want to write the equation. We know it's a vertical because that's the distance from our center to our vertex, so it's vertical. So I can write the equation, and we can talk about how I know the equation if it's vertical or horizontal here, and that's based on the denominator. Vertical applies to like our y values up and down, and you always put the A squared value underneath the axes it goes. So that's vertical, so that's like the y-axis, so the A goes underneath that. So B would go underneath the other one. Now I can substitute the numbers, so it's x minus my h, which is 2, all over b squared. B is 1, so we have 1, plus y minus k, which is -1, so I'm like adding 1 squared, over a squared. A is 3/2, so we have 9/4, equals 1. So that would be the standard form. Okay, let's sketch one. So here is our equation. If you look at this equation, you should see that there is no h and k. There's no parenthesis. But we have these coefficients here for x and y, so we want to get rid of those. We want to put it in the standard form. So I want to divide both sides by 16. It's also, you should see that because you want to get equal to 1. That's what the standard form is, always equals 1. So I divide both terms by 16. I get x squared for the first one, plus 4 over 16. So I have y squared over 4. So I can put this into fractions so I can see what my A, B, and C are. So for this example, because the bigger number, 4, is below the y, I know it's vertical. So then I know that 4 is equal to A squared, so A is 2. So then our B value comes from the other one, square root of 1 is 1, so B is 1. And so we can also know our HK is 0, 0, our center. The last thing to do is to find the foci if we want to plot those. C squared equals A squared, which is 4, minus B squared 1. So C squared equals 3. So C is √3. That's plus or minus, both directions. So there's our center, 0, 0. It's again vertical, so I'm going to go up and down A, so up 2, down 2. And I can plot use my B values. So I'm going to go right 1 and up 1, or left 1. And I can kind of sketch that ellipse. So here is a general form for an ellipse. So let's put this in a standard form so we can find the parts of it. So we need to separate our x's and our y's. And I'm also going to move the constants to the other side, which allows us to complete the square. So for our x's, we can't complete the square first because we have a 16 here. The y's, we have 25, so we have to factor that out. I'm only going to factor that out of the same variable. So just factor the 16 out from the x's. I have x squared minus 2x, and then plus, I'm going to factor 25 out of the y's. Get y squared minus 2y. So now I can complete the square. This will be plus 1. This will also be plus 1. So then if I'm adding 1, now this is not really 1. Even though I wrote 1, this 16 is being multiplied to it. So I'm really affecting this side by 16. So I should add 16 to this other side. And same thing here. This is 25 times 1. So I'm really adding 25 to that side. So I should add 25 to this side. So if I simplify that, I get 16 times, factored as x minus 1 squared, plus 25 times y minus 1 squared equals 25. Last step is to make this equal 1, so I'm going to divide by 25, divide by 25, divide by 25. Now I can rewrite this a little bit, like 25 over 25 can reduce, so I just get y minus 1 squared equals 1, but this is all over 1. The other fraction, I have 25 in the denominator, but I want to have this entire constant in the denominator. So instead of multiplying by 16 or 25ths, I could call that x minus 1 the quantity squared and then divide by the reciprocal 25 sixteenths. So now I have my entire value for a or b, which is what I need to find next. So in this, our a value is always square rooting the bigger denominator, which is 25 sixteenths. So if I square root that, I get 5/4 is our a value. B value is square root of 1, which is 1. And then our c value is found by c squared equals a squared, which is 25 sixteenths, minus b squared. So c squared is 9 sixteenths, which is plus or minus 3/4. So using these three numbers, I can then find the center, vertices, foci, and all the pieces I need. So the center is really just hk, and that's coming from the equation in parentheses, so it'll be 1, 1. The vertices, because my a is below the x values, I know it's horizontal, so I'm going to add my a value to my x value, because it's horizontal, of the center. So it's going to be 1 plus or minus 5/4. So you could write it like this, or we can evaluate that. Try to show you how I'm doing it, which would be 2 different points. And so I'm actually fine with you writing it as is, so you can have the 2 points written as 1. We also need the foci. Foci is the same variable, x value of the point of the center that we're adding to, but you just use b instead of a. So it's going to be 2, 1 if I add the 1, and 0, 1 if I subtract the 1 to that x value. So that's the center, vertice, and foci. Okay, the last one here, let's find the standard form for this equation. So we again group 9x squared minus 54x and plus 4y squared plus 40y, and then equals negative 37. We have to factor out a 9 here and factor out a 4 for the y's. So now we can complete the square, which this first 9 is really 81, so I'm going to add 81. And the second one, 4 times 25, is really 100. So now we can write that as 9 x minus 3 squared plus 4 times y plus 5 squared equals 144. Divide both sides by 144. Dividing each fraction by that, which reduces to 16 here, and y plus 5. 36 is there, and 1. So there is my standard form for that ellipse. I'm going to call that good for the night for ellipsis, and we'll see you tomorrow.